Okay, section 1.4, shifting, reflecting, and sketching graphs or transformations. This is super important. I know there's a lot of information on your screen and on your notes right now. We are going to highlight it and color code it and stick with those colors, so I highly suggest that you color code along with me to help you out this essential skill. So, vertical shifts, orange, it's orange on my screen at least. When we have plus or minus D at the end, that moves the graph up or down. You also might see K being used. You might remember K being used from your integrated 3 class, but we are going to focus on D because we've got a lot more variables, letters we need to use this chapter, this course. Then we have plus or minus C, and this is the same thing that you learned in integrated 3. So horizontal shifts, green, plus or minus C in that parentheses will move it left or right. You might remember it as being H from integrated 3. The thing you want to remember for that one is that it's always opposite what you think. So if it said plus 3, you might think, oh, that goes to the right 3. But since it's in parentheses, you do zero product property to take it out of the parentheses, so it ends up moving it left 3. So it's always opposite. Reflections, we're going to make all of our reflections yellow. When there is a negative in front of F, or when A is negative, we say it reflects over the x-axis. That's perfectly fine for you to say. I will more often say reflect vertically or vertically reflect, however you want to say it. When there is a negative, earlier I said we were going to use yellow for all of them. We are not. Yellow is for the A value. When there is a negative in the parentheses with X, I'm making that pink. That reflects over the y-axis or horizontal reflection. You have not done a horizontal reflection yet. This is new this year. It's not new to math. It's new to you this year. So horizontal reflections, if B is negative. Then for vertical, remember vertical is yellow. For vertical stretch and shrink, which we will say compress, not shrink, if the absolute value is greater than 1, absolute value of A is greater than 1. So if that number itself, remember the negative is taken care of up here. We don't care about the negative anymore, just the number itself. If it's bigger than 1, it's stretched vertically. You should remember that from last year. If it's less than 1, the absolute value, it's compressed vertically. The opposite is true for B. So if you remember your A rules from last year, it's opposite for B. And remember B we were doing in pink. If the absolute value, just the number of B is bigger than 1, it actually compresses horizontally. And if the absolute value of B is less than 1, it stretches horizontally. So we have 2 written in red there that do opposite of what you would think. So keep an eye out for those. So here is the equation that we're getting all those letters from. So earlier I made A, I talked about it at least, yellow. That is your stretch compress and your reflect vertically. A does vertical stuff. I made B pink. This pink, I think. Sorry, B. That was your horizontal stretch compress and your reflect horizontally. C is green. Remember that does opposite what you think, but it's left or right. And D is orange. That is what I did, right? Let's go back. Yeah, okay, good. D is orange. That moves it up or down. Remember that the 2 on the inside changed the X values and the 2 on the outside changed the Y values. Also, be extra careful with these ones because it's always opposite what you think. What we're going to do is we're going to make an equation out of that. Once you have it in graphing form, this is graphing form. We will talk about that probably in one of our first examples in a second. Once you have it in graphing form, you should be able to identify A, B, C, and D. And then you use those to find your new X and Y values. So your new X value will always come from taking the original X, divide by B, that's the wrong color, divide by B, and then add or subtract, right? It depends, C. Your new Y value will always come from A times Y, and then add or subtract, right? Depends on what it is, but plus D. this will be the formula we use. This right here, this graphing form equation is super important. And this right here, our formula to get our new x's and y's, is super important. You'll find the points, and then you'll graph the points and describe the transformations that have taken place. So here is our first example. So first of all, understand that this is just some random graph, right? If it's going to be a random graph like that, we will connect the points for you. And notice there's kind of a curve right here, right? It looks like it's a piece of a parabola. When you go to graph yours, you need to make sure it has that same curve, right? They're not just connected by straight lines. Our graph has a curve in it. These points over here are just the points that are plotted for you, so don't get confused by that. -4, 3, that's right there, right? -2, 1, that's right there. We just took the points for you and put them in a table. Then we've gone ahead and we've taken those same points and we've written them over here for you. So we're just saving you time. But I need you to understand where they came from. They came from the points in the original graph. The original graph is called f of x. Now we are going to take g of x, which is transforming f. There's that letter f, so you know what equation, what graph it's transforming. And we are going to do the math to find the new points that represent g of x, which is what this column will ultimately represent. So notice, this is not in graphing form. I'll go back. Graphing form, the b is outside between a bracket and a parentheses. It is separated from the x. This too is not separated from the x. So our first step is going to be to put this in graphing form. So g of x equals -f. It should say bracket something parentheses x parentheses bracket plus 1. We just got to fill in the middle part. So if it's just supposed to be a single x in the parentheses, then we need to factor out that 2. So the 2 must be pulled out as a GCF. If I factor the 2 out of there, I have to factor the 2 out of the 6 also. So divide by 2 and I get plus 3. Double check in your head. If you redistributed that, you would get that up there. Now it's in graphing form. Now let's color code all the things we have. We have A is this imaginary -1. B is this 2 that we factored out. C is in here, x plus 3. And D is down here, the constant. Let's write down our formula. This is going to be important. I put it in a box on the other page. Remember, our new points come from this formula. X divided by B plus C, but it might be minus, AY plus D. Again, but it might be minus. We have to pay attention. I'm going to color code this one more time. D, A, C, and B. Well, if you look at our graph, we should be able to figure out what all of those things are. So over here in our table, we're going to write what we're going to do to get those new points. So it's x divided by b. Well, b is that highlighted 2. It's pink. It's the 2. So we're going to take every x and we're going to divide it by 2 from the pink part of my equation. Then it says plus c, but remember it's always opposite. If it's x plus 3 in parentheses, that means we're actually going to subtract 3. From the green, we're going to do the opposite. That'll give me the x values. Excuse me. The y value is a, which our a value is that yellow negative sign, so -1 times y, and then it's plus d. And for d, it stays the same. Since it's the orange plus 1 at the end, it stays orange plus 1 at the end. So this came from the yellow in the front. This came from our constant. So this is what we're going to do each time to get our new points. Oh, here's something you should know about me. We all can understand that this column is going to represent points for x and y, and this column is going to represent points. However, I'm not going to put it in parentheses every single time. We're going to do a lot of these examples. Honestly, writing the parentheses is just too much for me. You need to understand they represent points, and I'll show you what I mean when I get there. Okay, so there's our new equations. X divided by 2 minus 3. So find your x. I'm just going to make it purple for right now. Here are our x's, right? We're going to take each of those and we're going to do the x equation to them. So I'm going to take the first one and I'm going to take the given x, -4, the purple one, divide it by 2 and minus 3. Well, negative 4 divided by 2 is negative 2. Minus 3 gives me negative 5, comma. That's the x value. I like to do all the x's and then come back and do all the y's. So now do the next x value. The next x is negative 2 divided by 2 minus 3. The next x, if I skip along, is 0 divided by 2 minus 3. The next x, 2 divided by 2 minus 3. I'm just taking each x value and doing that equation that we came up with to it. See if you can do the math on all of those and find all the x values. So by doing that, we find all the x values. Now I'm going to switch over to finding the y values. So I'm going to use, what color haven't I used yet? Blue. These are clearly all the y values. So one at a time, I'm going to do the y equation to find our new y values. So our y equation says do negative 1 times that y, which is a 3, and then add 1. So negative 1 times 3 is negative 2 plus 1. Negative 3 plus 1 is negative 2. Then it says take the next y value. Negative 1 times our next y value is 1 plus 1. All the way down. Negative 1 times 2 plus 1. Negative 1 times it happens to be 2 again plus 1. I'm just grabbing the y values from the left and plugging them into my equation up above. Do all the math and find all your y values. These are our new points. This represents g of x. Technically, they should all have parentheses, so that's what I was telling you. I don't always write these parentheses around them. You also don't have to write them in your work, but if it's ever an answer, make sure you write it as a point. Now what we're going to do is we're going to plot those new points, and we'll have our new graph. So my paper has graph paper on it, so I am going to use the graph paper on my screen, so add some tick marks to yours if you are not, well, my notes are not printed on graph paper, so I know you're not doing this on graph paper, so put tick marks on yours. And then I'm just going to plot those points. Negative 5, negative 2, negative 4, 0, negative 3, negative 1, negative 2, negative 1, negative 1, negative 3, and 0, 0. Okay, now this is where it's important. Do not do this. Straight line, straight line, straight line, straight line, straight line. Because the original graph was graphed up above and it has a curve. So you need to find where that curve is. It might be helpful for you to list out the transformations first. We're going to have to list out the transformations in the end anyways. So I will tell you this graph has 4 transformations. So from that first page, from this page, you're going to say stuff like this. Up, down, up 7, left 3, reflected vertically, things like that. And you learned this in Integrated 2 as well. I'll also tell you the yellow does one thing this time. The pink does one thing this time. The green always does one thing. And the orange always does one thing. So our A value, the yellow one, was negative. Negative A values reflect vertically. It's on the page. You're going to have to memorize it. Our B value was 2. 2 is bigger than 1, but it does opposite what you think. It compresses horizontally. Compressed. I have to write I'm just going to simplify it. Comp horizontally. You need the horizontally on there to be correct. B does horizontal stuff. The plus 3 is opposite. It moves it left 3. And the plus 1 stays the same, up 1. So this is reflected vertically. So I'm going to take this graph up here, and in my head, I'm going to imagine it flipped upside down. So that means the curved part would end up here. So I try to draw in the curved part where it belongs, and then the rest of it is straight. So this is a complete answer. I have the sketch, I have what happened to it, the transformations, and I have my points. Okay, number 2. Notice we are still using the same f value, so we've already filled in your table for you to remind you what the f originally was doing. Also notice it is not in graphing form yet, so we're going to need to write k of x in graphing form. 3 is fine, f. It should have a number between the bracket and the parentheses, a single positive x, and then like this. So we have to change the part on the inside. So clearly it's a 1/2 that I need to factor out. But when I redistribute this, that's going to give me 1/2 x. 1/2 times what is going to give me 1? It's kind of weird, right? It's got to be 2. Half of 2 gives you 1. So you can think of it like this. I'll use this page over here. You were doing 2 and you were factoring out, you were dividing by 1/2. I'm sorry, you were doing 1 and dividing by 1/2. Well, remember, we don't divide by fractions. Instead, we flip and multiply, which is why it gives us 2. But just kind of doing the opposite distributing is easier, I think. 1/2 times what makes 1? 1/2 times 2. So now it's in graphing form. Here's our orange. Green is in the parentheses. Ooh, that's an ugly green. Green is in the parentheses. Pink in the front. And yellow in the very front. See if you can come up with your formula for your new x and y's. What are we going to do? We're going to take every x and we're going to divide it by 1/2. Remember, the x's are kind of opposite what you think. So what's happening in here right now? Well, first they're adding 2 and then they're multiplying by 1/2. So we're going to do the opposite of that. First, we're going to, instead of multiply by 1/2, we're going to divide by 1/2, but that's the same thing as multiplying by 2, right? Taking half of something, the opposite of that is doubling something. So we're going to get 2x, and then we're going to do opposite of this. Opposite of plus 2 is minus 2. So this is our equation to get our new x's. The y equation is usually straightforward. 3 times y minus 2. That formula was on the first page of today's notes. Going to be super important. So I'm going to take every x. 2 times every x minus 2. 2 times the given x minus 2. 2 times the given x minus 2. All the way down. Take a second and start finding your x's, your new x's. And then y's. 3 times every y minus 2. 3 times the y value minus 2. 3 times that y value minus 2. All the way down. Do the math. These are my new k points. They should have parentheses, but I don't draw them every time. Set up some axes and sketch your new k. So if I'm looking at these numbers, there's no negative numbers. So there's no negative y values, I should say. So my graph can be down here so that I can fit it all on there. I'm just plotting the points. Okay, then before you connect the dots, because we got to find out where that curve is, try listing out the transformations. This one again has 4. It could have anywhere from 1 to 6 transformations. The yellow one's doing one thing, the pink's doing one thing, green and orange always do one thing. Yellow could do 2, pink could do 2 theoretically. So an A value of 3, that's stretched vertically. A B value of 1/2. 1/2 is a small number, but remember when it's in that brackets, it kind of does the opposite of what you think. So that's actually going to stretch horizontally. +2 does the opposite, left 2, and -2 is down 2. So this has no reflection. So the curve, and you can see it on your paper hopefully, right? The curve is going to be in the same spot. So these represent where my curve is, the hump, and the rest is connected with straight lines. If I can't tell, if there's a curve in the graph and I can't tell where your curve is, you're not getting full credit. This one really shows what a horizontal stretch does. So if you look at the gaps on your X's, like the gap from here to here is 2 units away, but the gap from here to here is 4 units away because it's been stretched horizontally. Same idea on the Y's. You can choose any points. If you look at these 2 points, the gap between those Y values is 2. The gap between these Y values is 6 because it was stretched vertically. So you can see how things are stretched or compressed in the numbers in the table. Okay, last one for tonight, number 3. Go ahead and read through that equation for yourself. That, paragraph for yourself. If you haven't noticed yet, I'm big on color coding, so I'm going to use what I know about transformations and match it up with my color coding. So it says g of x is the following transform function of f of x. It's reflected over the x-axis. If you flip over the x-axis, that's vertically reflected, so I've been making that yellow. Compressed vertically, it says vertically, that's been yellow. Compressed vertically by a factor of 5, that's yellow. Horizontal has been pink. Horizontally stretched by a factor of 3. Shifted 22 units right, left and right, that's pink also. I'm sorry. That was green. Left and right is green. And then 11 units down, up and down is orange. I don't know if you guys can tell orange from pink on your screen. I hope you can. So here's what we need to do. They said g of x is a function of f. So I'm going to leave some space, but do not forget the f. If you just have the x in here and not f, you are not transforming equation f. You're really doing nothing without the f in there. Now we're going to put all the stuff in the right spots. Color-coded, orange goes there, green goes in there, pink is in between here, and yellow's in the front. So it is reflected over the x-axis, so that means it needs to be negative, and compressed by a factor of 5. That means to compress vertically, you need it to be 1/5. Then horizontally stretched by a factor of 3. So to stretch horizontally, it needs to be backward, upside down. 1/3 actually stretches it, right? It's backwards from what you think. 22 units to the right. To the right means minus 22 because it's backwards of what you would think. And 11 units down means minus 11. I personally don't like the way this is worded. Chances are that would say 1/5 on the test. It's compressed by 1/5. As long as you put a number less than 1, right? In order to compress, it needs to be a fraction. Okay, we will practice this more together in class, and I hope you guys are doing well.